Hey, this is a video on right triangle trig for the ingenuity unit, and I'm gonna go over some concepts to help you guys get started. If you're given a right triangle, you're gonna be given a problem where maybe you're given two sides. If you have to find the side, use the Pythagorean theorem. And then if you're given two sides, you have to find an angle. You use the inverse trig, that's sine with the -1 up top, cosine -1, tangent -1. If you're given one side and one angle and you're asked to find a side, that's where you use SOHCAHTOA. If you have the opposite and the hypotenuse, and one of these has to be x, right? One of these has to be what you're trying to find, then you use sine. And if you're given the adjacent and the hypotenuse, and again, one of these has to be unknown, use cosine. And then adjacent and opposite, then use tangent. Okay? If you're given one side and one angle and it says find the angle, then you really just use 180 minus 90 minus your other angle, and then that'll tell you the other angle. So it shouldn't be too bad. If you are only given 3 angles, you cannot tell the side lengths. And if you're given 3 side lengths, then you can tell the angle. That's where you just use sine, cosine, tangent. Okay, all right, so let's go over some problems here. Number one says 7 over x equals x over 28. And so this is a proportion. So we're gonna cross multiply and set the products equal to each other. So it would be 7 times 28 is equal to x times x. 7 times 28 is equal to 196. And x times x is equal to x squared. From there, you take the square root. And the square root of 196 is 14. So x is equal to 14. And you can also write this, I just left the x on the right because it followed down. But you can, I mean, it's the same thing as x equal 14, right? So, okay. Next one has congruent markings right here and here. And basically it says, what we're supposed to do is find, we'll just fill in the whole triangle. So we're supposed to find the sides, but we're just gonna fill in the whole triangle. So since it has congruency markings, you know that this is also equal to 9 root 2. And this is 9 times root 2. We just put it together like a coefficient. So it's coefficient and radicand. I want you to know that these are really just multiplied. So this is a 45, 45, 90, since we have 2 congruent sides. So this is 45, also 45. And then with the special right triangles, 45, 45, 90, it's the hypotenuse is the length of the leg. So it's the leg times square root of 2. And so this is 9 root 2 times square root of 2. And then when you multiply these, I like to teach it, just multiply the outside numbers, the coefficients together. So this is like a 1 is right here. You don't have to write the 1. So 9 times 1 is 9. And then square root 2 times square root 2 is square root 4. And the square root of 4 is 2. It's not the square root of 2. The square root of 4 is 2. And then 9 times 2 is 18. And so this side right here is 18 in length. So 9 root 2, 9 root 2, 18. It says, find the third side in the simplest radical form. So you have 2 legs, and then this would be C. And when you use Pythagorean theorem, just know that the hypotenuse is always C. A and B you can switch, but for C, you have to know that this has to be the side that equals, right? So 12 squared plus square root 39 squared is equal to C squared. And then 12 squared is 144. The square root of 139 squared, it just cancels the square root, so it's just 139. And then 144 plus 39 is 183. And I'm sorry, 183 is equal to c squared. And then I'm gonna look to see, well, okay, I'm sorry, I'm gonna square root both sides to cancel the squared. So c equals square root 183. This you can express as a decimal, 13.53. Notice I'm using the squiggly lines because it's not exact. I'm gonna check. I wanna check to see if I can simplify this. So I'm just gonna think about perfect squares that could be in it. 9 could be in it, 49 could be in it. Let's see, it's odd, so it's not gonna be, I mean, it'd just be, I don't think that it would be anything even. So 183 divided by 9, it's a decimal, so it's not going to be that. 183 divided by 49, decimal, it's not going to be that. So I think 183 is just the simplest form. So it's either one of these is correct. Okay, right here we're going to find x and y. And we're given the hypotenuse. And so this is your target angle right here, or this would be what we call theta. Okay, so it would be, let's see, to find x, this is the opposite side. So since we have opposite and hypotenuse, we would use sine. So it would be sine of 52 is equal to the opposite over the hypotenuse. And then from there, you just multiply both sides by the bottom. So x is going to be equal to 46 times sine of 52. That's 36.25. Okay. And then for y, start at theta. This is touching theta, so this is the adjacent. So I have the adjacent and the hypotenuse, which is cosine. So cosine of 52 is equal to the adjacent over the hypotenuse. And again, I want to solve by getting y by itself, so I'll multiply by 46. Multiply by 46, and then come over here, do 46 times cosine of 52, and that is 28.32. So 28.32, and that's how to find x and y. Find n to the nearest degree. So this time I'm given two sides and I need to find the angle. And so this, I'm gonna use the inverse trig. Okay, let's see. I'm given the hypotenuse and this is the opposite. So that's inverse sine. I'm just gonna put it right here. Inverse sine of the opposite over the hypotenuse. So for this one, I'm gonna do shift or second, and then sine, so it gives me the inverse sine, and it's gonna be 12 over 20. That's it, 36.87. Okay, and then here I'm given the adjacent over the hypotenuse, so it would be inverse cosine So same thing, I'm going to use shift cosine 15 divided by 21. 44.42. Okay, I'm given two sides and an angle, so theta. So the first one is going to be opposite over adjacent. So this would be tangent. So this is the adjacent and the opposite. So tangent 55 is equal to the opposite over the adjacent. Okay, so multiply by 7 both sides, and you get 7 times tangent of 55, 9.997. So really, it's going to be about 10. The next one is going to be the adjacent. Now you can use this. You can use this to plug in to find x. But since this is an approximation, I'm just going to use the exact number. So it's a little bit more precise. Let's see. It'd be adjacent and hypotenuse. So adjacent and hypotenuse would be cosine. So I'm going to do cosine of 55 is equal to 7 over x. Okay, so now this is the adjacent, this is the opposite. I'm sorry, this is the adjacent, this is the hypotenuse, and I'm going to solve for x. Now, I can't multiply both sides by 7, that's not going to work. So I'm going to show you the long way, and then I'm going to encourage you to memorize the shortcut, because it's always the same way, okay? So if I multiply by x, this cancels. And then if I divide by cosine of 55, this cancels. Okay, so what we did was we have x is equal to 7 over cosine of 55. And that's the way it is. It's always going to be the number divided by the, either it's either going to be sine, cosine, or tangent. But this is always for when x is on the bottom. See, over on the last 3 examples, the unknown was on the top. So 7 divided by cosine of 55 is 12.2. So x is equal to 12.2. Okay? Was that it? Was it the last one? That was the last one. Okay, so there's some more notes in your slides, but just going over them real quickly, this explains the inverse trigonometric functions. You have sine, cosine, tangent, which is just ratios. You also have cosecant, secant, and cotangent, which is just flipped. So sine of A is equal to side A over side C, and cosecant of A is just side C over side A. So it's just flipped and flipped. Angle of elevation you need to know is going up. Angle of depression is going down. These are vocab words you need to take with you from now on. Okay, all right. Hopefully that gets you started well, and good luck.